On to more important stuff. We have here with us Merlos and Dario, and they're going to talk about the building the Cyber Saiyan badge. So give them a great round of applause.
Okay, so can you hear me? Yeah? Okay, good. So, welcome everyone. First of all, thank you for joining our talk. As you can see, and the talk is about the badge we built for RomHack Camp with Cyber Saiyan, that is the non-profit association that I founded with other guys years ago. And but we will present later this stuff. And first of all, who am I? So I'm Giovanni Mellini, aka Merlos, and currently I'm the CISO of Satispay, that is an Italian fintech company since 4 years. And I was head of information security of VNAV, that is the Italian air traffic control provider, for 12 years. Too much. And before I did a lot of network, system, Linux, whatever. And so, as I said, I'm the founder and president, actual president of Cyber Saiyan. That is a non-profit association that I founded in 2017 with other guys. And today is one of the biggest community in Italy. So we're on RomHack conference. That is a cybersecurity conference that we run in Rome each year. This year will be the 8th edition. And we do also training before the conference, and we did in 2022 camp in Rome, not like this, smaller one, and we will have another camp next year in 2026 in September. Of course, if you want to join, you are more than welcome. So, before giving the word to Dario, I present a little bit Cyber Saiyan. So you can meet us at Cyber Saiyan village that is inside Milliways, straight on the left, on the south of Milliways. You can find us with other 3 associations that are Metrolographics and Summer Camp. So we have the cluster Grappa, probably everyone knows about Grappa. And so we do a lot of activities, So we do activities in the village, like the Battle of Saiyan, that is a permanent installation with robots. You can play with robots. And so we have, of course, the badge, and we will have tomorrow a contest of the best tech of the badge. We will have a matriciana within Milliways this night during frac party. So I was cooking a matriciana before joining come here. And we have a guy from us that do electronic music live set during Milliways party, and we have three talks during this Y camp that is good. So, Dario?
Hi, everybody. I'm Dario. I'm a proud member of the Cyber Saiyan. I associated some years ago. I work as now as developer principally, but I have a history as a sysadmin, network admin. Maybe I have done many roles in my career. And anyway, I have a passion about electronics, embedded system, working on this electronic hardware, digital and analogic.
Okay, I go? So as you can see, so we start with the motivation of making a badge for Y. Then you will see the software and functionalities that the badge has. So I present this part, and Dario will present the hardware part. So I'm not an hardware guy, so it's business. And so why the badge? The badge comes from an idea we had for the past camp in 2022, but we were not satisfied about this badge because a lot of things, and so we decided to start from scratch this design of the new badge from the hardware part and the software one. So here you have the GitHub page where you can look at the code. You have everything, so the schematics, the source code, whatever. You can check and start hacking with the badge if you want. And so this is motivation. So improve what we did before and what we didn't like before. And so in the first part, I present you this badge. So as you can see here, we have, this is the front and the rear of the badge. So someone of you probably already has, so you can look at the badge, but I speak more about functionalities of the badge. So the badge is quite simple at the end, and the goal is to enhance our village experience, okay? So it is designed to recall the Dragon Spheres. Probably most of you know Dragon Ball, whatever. So Cyber Saiyan is a little bit contaminated by Dragon Ball, you know, and from the name for all the things that we design is based on Dragon Ball, whatever, and also the badge, of course. And so we will see the goal is to summon Shenron, of course. So the core of the badge is ESP32 SOC, and so Dario will go deeper on the details, but as you can see, you have a 32-bit single-core RISC-V microcontroller and 400 kilobytes of internal RAM, Wi-Fi and Bluetooth low energy in the antenna, and then we have programmable GPIOs that you can use for hacking. And so in the front part, you have 7 RGB LEDs that that blink, and we will see more details how are used these LEDs. And in the back, you have a TFT screen, so a LiPo battery. This battery burns or not?
No.
We hope no.
This one, no.
A reset button, hardware reset button, 2 dial wheel that are the way we interact with the badge, and so as I said, 8 connectors for configurable for expansion. Once powered, the badge is assigned with an ID. The ID is a number between 1 and 7, and this badge starts advertising its number around using Bluetooth Low Energy. So think that the ID is created using the MAC address of the Wi-Fi, so it's unique and for the badge, and on reboot you will have the same ID. So as I said, you have 2 ways to interact with the badge. So long press and short press. So think about, so we have a screen, you don't see it, of course, but we will see better. You have a screen, but you can scroll down and up to the screens, and you reach different areas of the badge. And sometimes you can interact with each screen. You interact with the screen doing short press. So in the code, we detect when we have a long press and a short press from a right up button or down right button on a left button. Okay, this is the idea. So we have, it's quite simple, but it works. So at the beginning, so we have the Cyber Saiyan logo. This is the main, so this is like the home screen. Here we implemented 2 Easter eggs at the end, and and you can find, probably you see it there. So one of these is like the rainbow. Don't know, so this show the capability of the RGB LEDs. It's quite simple, but it's powerful. And we have also another Easter egg, but I leave to you to find it in the code, of course. And this is the home screen. You cannot do anything. So to move to the next screen, you have to press the button down for long press, like 1 second. And you move to the second screen. Here we have the agenda, the schedule of the village. So as I said, the idea was like also to give to the people that comes to the Cyber Saiyan village also something to understand what is happening. So we put here the schedule of the village, and you can scroll down with short press, scroll up and down with short press on the agenda. And we will see that you can update the schedule. Of course, the schedule is offline. This means that we built the firmware of the badge, and we have a JSON file that is called schedule.json, of course, and we have the static village schedule, but we will see we can sync the schedule with the file we have on our web server. And it's good to understand how it works, because so it's quite challenging because we have few memory on the badge. So when you do tasks like this, you have to like do garbage collection, be careful with the memory, the allocation, or whatever. Next, so the third screen is like the badge radar. Probably most of you recognize this, like Dragon Ball radar, of course. And so as I said, so the badge speaks Bluetooth low energy with other badges, near badges. And this means that it can understand what badge we have near, and this is shown here. To calculate the distance between the badge and the other badges, we use the RSI value here. And so we like compute this and try to put the other badges around and in a consistent way. Of course, we cannot have a spatial view, but just a speculation of the distance of two badges, because we don't do triangulation. Someone yesterday told me, you don't do triangulation. Yes. No, we don't do it. But you can do it and win a flipper zero. We will see how. And so other than that, we have also another interesting functionality of the badge. So as I said, we have the antenna, so that is Wi-Fi and Bluetooth low energy. And so we have these two functionalities that you can use, like the badge can become an access point. So if you turn on the access point, the badge becomes an access point, and I will show what you can do. Or you can sync the schedule, as I said. To turn on the access point or sync the schedule, you should use the short press. Short press up, turn on the access point, is the way we interact, remember? Short press down, you sync the schedule. What does the badge? Tries to connect to the open Wi-Fi of Y, so is coded in the code, of course, in the configuration file. So we have a file that is called configuration.json, and inside this file we have the name of the Wi-Fi. If you put the password here, the connection is authenticated, and it tries to authenticate. If you don't put the password here, the connection is open and try to connect directly. And that's it. So of course you can. So this is something that you use when you have like big event, big schedule. For example, for the camp, RomHack Camp in 2022, we had updates during the days, and of course some people try to update the schedule on the badge and worked well. So now it's like more static. We have 6, 7 activities, and that's it. And I think that access point functionality is quite interesting. So because, as I said, you move up and this starts, and you can connect to an SSID with a password that is unique for the badge. Also here we use the MAC address of the Wi-Fi to create the SSID and the password. And then you can connect to a web page that is not HTTPS, but that's it, of course. And we implemented a web server, a basic web server. that in the C code of the badge, and the web server interact with the backend of the badge. What you have here, you have a simple web page, and it's quite challenging to have this kind of stuff inside a web page because, as I said, we have memory problems when we do requests. We have receive a response from the badge, and we had a lot of tactics to like compress, minify all the HTML and JavaScript stuff. And here you can check by yourself. You will see the cron tab of the schedule, of course, the radar in a fancy way, and you can see some information, and then you can also change settings, basic settings of the badge, like the web admin password, the Wi-Fi SSD, and whatever. And if you're a good hacker, you can unlock the Tetris, and you can play Tetris. That is cool also. And last but not least, the last screen of the badge after the access point and sync screen is Snake, of course. So this means that you can play Snake. Why not? And I show you a small Okay, just fun. So you notice that the Tetris blocks are customized. So we have stickers on the village with like these blocks, so you can build your wall of Tetris. And okay, so next. Oh. So as I said, this is the GitHub page. If you want to start looking at the code, we have everything is open source. So if you want to contribute, please do it. If you want to buy a badge, so of course this badge is like it's built. So we invested a lot of time and effort and money from the association. So we are trying to keep some money to cover the expenses of why. So if you want to take a badge, so we appreciate it and you can support us. Here you can see the code. So we have like a main folder with all the C files. So as you can see, it's quite simple, not too much files. So we try to be clean. And so this is the HTTP server. So the sync function, snake function. So you can look the part of the code you want. And here you see the data folder where we have all the HTML stuff that is quite interesting also how you can optimize it. And the two default scheduled JSON file where we put all the configuration. Personally, I use VS Code to work on the code because there is PIO, that is a library that this extension that can help you on the development. So if you want to try it and you don't know how to start, on the GitHub page, we have all the information. But if you want to come to the village, we can say to you how to start on that. And okay, so Dario.
Okay. After the software, before the software, we made the hardware. As said, the hardware was upgraded version of the last badge. It had some problems that we resolved with this version. That may be improved a lot more. But the base is this. The CPU is the same. We taken the same processor because it's a very low power processor. Have only a single core, but it's good for our application. This CPU have a 400 kilobyte of RAM, but it's very fragmented, so it generates some problems during software development. The flash is the internal flash. We use the version that have flash inside. 4 megabyte, that is half used for software, for the microfilm we made, and the other is the storage used to the resources about the web pages, the configuration files, and all this stuff. The Wi-Fi and the Bluetooth this time is irradiated by a ceramic antenna. In the last version, they had a PCB antenna that worked well, but this ceramic antenna is better. The GPIO on the CPU used all used by the function. There are 16 maybe. It's not a very big number of GPIO because using all the interfaces like ASP for controlling the display, I2C for expansions, buttons. We occupied all the GPIO available. In this version, we had a great improvement, that is a reset button that was not available in the previous version. So the hot argument is the battery. On the last version, we had simple non-rechargeable batteries, just Stilo, that lasted very quick. They just some hours, one hour, less than an hour. So this time we used a battery. We used a very standard IC chips that are common for this work. The TP4054 is very standard. It's constant current or constant voltage battery charger for lithium ion polymer in some batteries, and work very well. And we added the protection chips, standard anyway, to the DW01 that have implement protections against overcharge, over-discharge. And protection to save the battery for overcurrent if there is a short circuit or something. Anyway, if you like fireworks, there is on the PCB the possibility to disable the protection circuit and make explode the battery if you really want. No, these batteries have a protection circuit soldered inside, so are already protected for short circuits and over voltage too. So there is double protection from the battery and from the circuit that we made. The power. To power all the other, we have a digital section and the maybe analog session that are the LED and the display. So we need 3.3 volts for all the digital parts, the ESP, all the other logic circuits to drive the display, to control the backlight, the expansions. So we provide 1.3 ampere of power using a common step-down converter, because the LiPo battery may be charged at 4.2 volts. So to be safe and using a switching mode regulator, we adopted anyway step down. There is anyway it's possible to enable a low dropout regulator that deliver less than half ampere. That is useful if you want a very low noise from the power stage, and obviously for low power application, because it can deliver less than half an ampere. The step-up controller for the 5 volts, 4.75, I've calculated by settings resistors all the voltage, is there to power the LED on the front, because they need 5 volts to operate correctly. So we had to make a step up. The power is 2 ampere, but the 7 LED only take 100 milliampere. There is 2 ampere because you can chain other LEDs and control more LEDs with the same order on the expansion port. We will look at that later. The I/O expansion. We have another chip that controls the backlights of the main display. The display is a standard ST display on SPI bus protocol, all available in the software library that we used. Open source, everything. So the backlight is controlled by 4 output of this expansion chip. The expansion chip have 2 ports with 8 pins. So all the other 12 I/O are available to be controlled as GPIO or functioning as RGB LED driver, because the chip accepts a set of commands that can work for controlling LEDs. All these expansions are available on the side of the badge. Okay. So the front RGB LEDs are standard on my best common WS2812 LED. This type of LED is in reality a chip with attached an RGB LED. It is controlled by a single wire, so we have only ground power and only a control line that have can be DC chained to control a very long string of these LEDs. We use this type of LED because in the previous version we had single RGB lines from the chip that we looked before connected, and this was some difficult to pilot the driving all these lines, all this control. The benefit is that less power used by LND, and that can be extended easily the string of LED. In this version, we used a display that can be that have the layer, the touch, the resistive touch control. So it's not capacitive; they have to be pressed. And because we have used all the pins GPIO from the ESP32, we have to use a chip that can control the touch on the display. We use a very big, important chip that is common on the open source libraries, so can be easily integrated in the software. In this version, we have not used it anyway. It's controlled on the same I2C bus, so the address is specified by setting the resistors that are the pads, the resistor pads available to change the address, with some big on the talking about SMDs is strange, but big resistors. So even manually, it can be changed the address for the chip if you have to connect other I2C devices that share the same address. All the documentation is from Texas Instruments, is available. There are many libraries. It can be easily upgraded, the touch functions on this with this display and controller. As more bonus, this chip have a pin used for analog digital conversion. So we attached a resistor partition on the batteries, so you can read the actual battery voltage using this same chip. So another function that can be enabled because all the system chip charge the batteries when the USB-C is connected, but to power on and power on the processor to power on in battery mode, you have to switch the switches that is available on the badge. So, with all the expansions are, we can go back to the photos. Così si vede. Okay, this one on top and left of the back. You can get you can see the connectors that are standard 1.5 mils connector. So they are easy available on market, maybe just with the wires connected anyway. So it may be simple to get one, and they are spaced, so we can the wires don't interfere with others, and are separated. On the left side, there are the LED expansion IC pins, and on the top we have the processors, the ESP32 pins. So the bus I2C, ESP, one wire, serial port, and the power generated by the regulators. So 3.3 volt, 5 volts, and ground, obviously. So we can see all the very quickly the pins. The pin numbered 1 have always the ground connection. So for the ESP, that are standard master, slave, clock. And there is the data command for the display, and the chip select for the display. So if you have to connect, you can only connect another SPI device. You have to negate the chip select signal. So if you intend to use the display, you can have only another more device on the SPI bus. The I2C connector contains the I2C signals, and the named one wire is the signal from the WS28 LEDs. So you can extend the strand, the LED strip, using that signal. The I/O on the left are arranged on the sequence based on the port of the chip. So via software, the AW9523 chip can be programmed as a general I/O or LED controller, so you can change colors in this way using standard RGB LED. The other connector is labeled RS232, but contains the transmit and receive signals directly from the ESP32. And the buttons pin. The buttons pins are the same used as bootstrap on the ESP. So pressing button A, you can doing boot, you can enable a loader mode, so you can only load firmware in this way. Useful if you do something wrong updated in firmware and it locks. And the button B is the other pin used for enable external flash, but this type of chip cannot be equipped with external flash. So the function is embedded on the chip, on the ESP, but is not available for expansions. So anyway, you can extend the buttons with other hardware or use these pins for something else. And the last expansion connector is the power. So you can take all the 3.3 volt or 5 volt ampere. But remember that the battery in this way is only 1,000 ampere hour. So it can drain very quickly if there is a very high power usage. There is a second connector for the battery. If you intend to use another battery that has the smaller connector type. These are the most, not standard, but common connectors available maybe on a Chinese market for battery. E così. Allora.
Okay. Okay, so thank you, Dario. At the end, so if you want buy the badge, as I said, and so we sell it for 35 euros. So the cost of the badge for us was like 21 euros. So I think that is a good price for the badge. So you can support us, keep doing this stuff for the next camps. Nothing. If you want to test it, we have 4 or 5 badges here. So if you are interested, we can speak about that outside. You can go to the village that is very near. So I think 2 minutes walk by there. And so, thank you.
Thank you. If you want, we have some time for questions.
Okay. Yes.
Are there any questions? I see some hands. Let's start here.
Hello. You have a very nice hardware. I love it. Very handy. Playful, of course. Perhaps quick question. First, do you have the schematic of the dimension to create a 3D case?
Yeah.
First, and the second one, more long-term question. Do you have plan for all the development, for example, I would love to bring it to my next camp, and do you have any ideas for that? Dates?
Yeah, I think the schematic are all on
it's all
GitHub
open
repo.
source, open hardware, open source. The hardware, the software is all available. The schematics and the Gerber files, the fabrication is all in a KiCad. Was made with KiCad, so open source software used even for the projects.
So I think that components directory is
The component, no.
The schematic. This one?
Hardware, hardware.
Hardware directory. So
In the hardware directory, you have all the data sheets for the IC, the chip used, and on the main directory, Dragon 4L R2, there is all the files used in KiCad with dimension and even the production files. So the Gerber files used for the fabrication from the China. We can name the producer the JLC PCB that made very good work.
yeah, and for the second question, I think that we can. So,
Another camp, for example, or something like that.
so the idea for the next camp, because so now we made this, I think that we started the project at the beginning of this year, more or less, with the idea. So we came up with the idea to take the old badge that was like outsourced to the Chinese company, and they made not a good job in terms both of hardware and firmware. So I remember I found tons of bugs on the firmware. We rebuilt the firmware from scratch, practically. And so we started with this idea because we said, oh, the idea was cool, but, you know, the making was not so cool, so we started again. But I think the project is completed from my point of view for this kind of badge, no? And I think we already have some ideas for the next camp badge in Italy, RomHack Camp, but it's not something that is an evolution of that. Probably is more related to music because Chrome, that is our friend, so he's speaking already with Dario. But if you want to speak for some announcement, so we can speak because I'm more interested in that. So of course, for the other part, Dario is the master. I can help just on the firmware, but so we can speak about that. I will be very happy to see the the badge evolving. So I think that we have a lot of potentialities with this badge. And so we did invest a lot of time in like adding functionalities for the previous batch because, to be honest, we had 3 prototypes. So we had in the first 2 prototypes we had a lot of problems with batteries,
with batteries and
recharging
antenna.
And the Wi-Fi antennas. So I think the last prototype was a month ago. More or less.
Well, 2 months ago.
2 months ago.
2 months ago.
And so it was like the deadline to print 200 badges, and we were lucky that everything was working. But I think that an evolution can be so we can work together if you want.
Okay. We have another.
We can speak in over here.
We have another question here in the back. So for a final question.
Thank you. Is there any particular reason why you chose that specific?
Cannot hear. So.
Oh, sorry. Is there any reason why you specifically chose the 7-star Dragon Ball instead of the other ones? And if not, then did you guys consider making the badge look like any other Dragon Ball? You know, like.
So didn't understand. Can you repeat? Sorry. So,
sorry. Did you guys consider?
Yeah.
Did you guys consider making the badge look like any of the other Dragon Balls that are out there, or was it always from the original, idea of the design for it always to be, the 7-starred one?
No,
I'm sorry. Can you repeat?
Sorry, it's our fault.
I understand. When you guys first came up with the design of the badge,
okay.
did you guys originally, was it always, at the start for it to be a 7-star Dragon Ball, or did you think of making it as, the other Dragon Balls too, like the 1-starred one or the 6-starred one? Or was it just always from the jump?
So what was the idea, the original idea? Yeah. So the idea years ago was, because it's like Cyber Saiyan we founded and we had always the Saiyan in mind. And I cannot remember why we decided to make a Dragon Sphere for the badge, but probably because for the 2022 camp, we made shirts with that had a particular design, and we had you remember the probably so like the visor that had you remember that? You remember the visor? Yeah? So we had this kind of shirts for gas stuff, whatever, and so we said so that this kind of badge was like perfect fit for the shirts. So it was like that. And I don't remember really why we came up with the spheres. Probably it was Alberto with this kind of idea, because we are all fans of Dragon Balls. And so it was like something like this. And so I think it was like a design choice, more or less, because like was cool near this shirt. Sorry for not understanding your question. Sorry.
Very well, thank you. A round of applause for these guys. Thank you.